So we'll start off with some kind of introduction of us, and then we will look at a short overview of API management, so you all know what the product actually does and what components are important. And then we go more on the main parts of the presentation that will be talking about how we actually get the APIs into production, and with demo around that also. So a little bit about us then. So I'm Samuel Kasper, work at Solidify as a principal consultant. I like skiing, not good at that, but yeah, I do it. It's fun. Been working with integration for quite many years. So I started off with the Business Server in 2005 and sort of got stuck in the area of integration. And then after a while, started working with Azure. Yeah, and of course, then API management that we will be talking about today.
Hi everyone, my name is Mihai. I'm also working as a principal consultant at Solidify. I usually help our customers with cloud, Azure in special, DevOps, DevSecOps, code quality, and I even hold some workshops into these areas. Magnus, do you want to say a few more words about Solidify, or should we skip?
No, we can. Now let's get this done.
Okay.
Good.
So let's start with a short introduction to API management.
Yeah.
Before we move on, we would like to know you better, and we wonder how many of you know what API management is.
Yeah.
How many of you actually work with it?
Oh, yeah.
How many of you thinks it's very easy to integrate it with existing DevOps or software development pipelines? Okay, no one.
No hands.
Okay,
It's a tricky area, yeah.
That's what we wanted to see.
Of course,
Okay.
of course.
So let's get started.
Yeah, okay. So API management is a product from Microsoft, one of the products in Azure Integration Services. And you use it for a number of different areas, actually. So you use it to create a facade where you can decouple your APIs or the APIs that are in the backend from the clients. And by decoupling it, you can also have it as a middleware where you actually protect your APIs, use it for caching, for performance also. And in the way you can do some monitoring of it, both of actually the traffic that is passing through API management, but also the usage. So you can see, okay, how many actually use this API and eventually charge for usage or eventually for the clients actually using, you can charge them. And for the developers, you need to have some kind of interaction with your developers, and the API management has parts there for discoverability, where you actually can find what APIs you expose, see documentation, and actually get access to the code itself. And the backend APIs could be quite different. It could be the APIs you develop. So you develop something that is in Azure, and you want to expose this either internally or to the world, and you use API management for exposing. It could be Azure APIs. I've seen at many customers that they expose some APIs to actually create resources in Azure. So you have a call, and let's say that you create a user, and that starts off a process that does something. or it could be some API that's been around for a while, that is on premises, and you want to expose it to the world. And it could even be that you buy some service. Let's say that your company buys access to a weather service, and you want to expose it to different solutions in your company, but you want to control the usage because that gives you some costs. So that way you could expose it through API management and and control the costs. So we have some APIs in the backend, and we could see that it could be hosted on different places. And here you have three main components. You have the Azure Portal, where you actually can go in and publish your APIs. And you have the gateway that is actually where the traffic is going through. And you have the developer portal, where the developers will be getting access to the APIs. And we can control, and we will see that we have different alternatives, how the traffic actually will flow through API management and to where the API is. So you have the API publishers, and they could use the Azure Portal, but the main part, the most important part, I would say, of what we're talking about today is actually the work of not using the portal, because we want to, in a controlled way, actually get the APIs to the gateway, to the developer portal for our users to use it, but without doing the clicking, having a safe and good process. So the publishers work with the portal or with some kind of process to get that out. And you have the application developers. They have the developer portal to access the APIs, to get keys and permissions to use the API. And they release their applications, and the traffic goes through the gateway. And the gateway can be hosted actually everywhere where you can have Kubernetes. You can actually host the gateway. So you could actually have both a gateway in Azure, and you can have a gateway, let's say, on premises, because you have some APIs that are on premises, and you want to be close to the clients that are in your internal network. So that's completely possible to do. Or if you have, let's say, if you use AWS, you could have it hosted there also if you want to.
Thanks. So before we dig more into demos or how we set up this for one of our customers, let's dig more into some features that we used for in our implementation. So any questions until now on API management? If no, let's continue. So one of the features that we used, which is not only an API management feature, it's a feature that is generally available on most of the Azure services. It's a managed identity. And what it means is that an Azure service will get an identity, system assigned or user assigned, that it's using it to access other Azure resources. And in our case, we use it, for example, for retrieving certificates for custom domains from Key Vault. And we also use it to retrieve other secrets that we used on some of the API policies for pre-processing the request before proxying further to the backends. Another feature, it's a set of features, let's put it like that, that we use to scale our instance. So for scaling the instance, we have a few options available. We can change the tier of the API, and there are a few versions available: developer, basic, standard, premium. it not only contains the capacity or the performance, it also the tier also controls the features that are available. So you might not have the same features for premium and standard. So some features will be available only on the standard tier. So if we take a quick look at how it looks.
Yeah.
Good. So here we have a comparison between different tiers. What I want to emphasize is that we have so-called let's see where they are, scale out units, and we can see that each tier has a certain maximum number of such units. So for development or for developer, we have only one scaling unit. For basic, we have 2. Standard 4, and for production, we have 12 for each region that you deployed. Also, multi-region is only available in the premium, and also network integration.
We have a question.
Could you specify what a scale out unit is?
Yes, so that's also something interesting. It's an abstraction over resources like memory, CPU, and the length of the queue for the incoming requests, right? So if we look here, the capacity for the unit also depends not only the number of units but also the capacity of the units varies between these tiers. So we can see here they give the throughput, which is not really correct in some sense, because as I said, it's an abstraction of also on the length of the queue and CPU and memory. So if you have, for example, APIs or endpoints that have policies that consume CPU, then you won't reach these numbers, right? Good. So another option to scale is to manually configure this number of scaling units. So you can scale up and down manually. Works fine. Another option is to use the auto scale. Again, this is available only in premium and standard. And you can set up rules based on the capacity, right? What's important to know is that only units in the primary region, if you use multi-region, only units in the gateway in the primary regions are scaled out. The rest of them will remain the same. And when it's also important to notice for those who are using redundancy or availability zones, if you have, for example, if you deploy to regions that has 2 or 3 availability zones, then you need to increase the number of units by a multiple of the number of availability zones, right? So that's also important to notice. Okay, we can, for example, for reducing the latencies, if you have customers spread across different geographic regions, we could use multi-region deployments. API management routes the requests to a regional gateway based on the lowest latency pattern. It's not possible to change this pattern, right? So if you want to change it or to use some other strategy, then you will need to deploy a traffic manager in front of your API management and do the routing yourself. If the primary region goes offline, then you won't be able to have access to the control plane of the API management, and you won't be able to access the developer portal because those are not replicated across regions. Also important to notice, if you deploy the API to different regions, don't expect to have much better latencies. Only you will get better latencies for the cached request. But if you have only backend in the primary region, then it will still route back there, right? So good to know. Best practice is to replicate also the backends into those regions or keep them close. There are different networking options or different ways to inject API management instance into a network, right? So the one deployment option is none. This is the default one. Then you just deploy the API management into a public. Then we have the external option, and here the API gateway and the developer portal are accessible from the public internet via an external load balancer. On the other hand, if we deploy an internal version, both the API gateway and the portal are only accessible from the internal network. Quite good options. Again, they are just available for the premium. But if you want to use standard, then you could use private endpoints to be able to reach endpoints or backends in VNet. Because there are so many options of deploying API management, we need also to think about security, right? So this solution is somehow similar. It's a simplified version of our setup that we ended up with. And what we recommend is to deploy an internal. If security is important, deploy an internal API management, and then have an application firewall in front of it. You could achieve some of the, if you want to be OWASP top 10 secure, then you could achieve those only with policies and so on. But I think obviously it's much better to use a application gateway or some other network appliance. Back there. Do you have any questions on this topic?
Crystal clear.
Let's continue.
So the setup that we'll present today is the result of customer engagement. So a customer contacted us and wanted us to help them with a solution, and we have some conditions to work with and some really important requirements. So they have. It's a company that is in many different countries, and they have teams developing APIs in different locations, and they're quite independent. So they have both when it comes to the development technology, language, operating systems that the different APIs are running on are different, and the teams themselves have no experience on Azure Terraform or API management. So that was sort of, this is the landscape you will be landing on, and they had some requirements that the infrastructure as code should be in Terraform. That wouldn't be our first choice. Probably we would go for Bicep or ARM, but the customer is doing Terraform for a lot of other things, so it's completely natural to actually do that. Then they wanted the teams to be independent, so they wanted the teams to actually continue doing their work, just giving them some guardrails to actually get into the API management in the right way. And this is actually just a little part of the entire project that we had handling these things. They wanted to have some kind of standardized way to actually get the APIs into having some validation of what is actually coming into the API management, and some documentations for teams, because they have new people coming in, starting to work, creating new APIs that they're going to use, and they need to actually get to know how the platform works. And they wanted to improve security also, because when we started, they were doing a little bit what they wanted and not always the optimal things. So we made some decisions. So we decided that we wanted to separate some different concerns. So if we looked at the platform, so API management itself, the service, should be in one pipeline. Mihai will show you the different pipelines later on. And we had some common components. So you have like things like products. Eventually you have an API that belongs to 3 different APIs that belongs to the same product. And you want to treat them as one. So we had like products groups, and after these, something called fragments have come that are snippets of code that could be used from several locations, and that could also be a common component. And then we have the API specific. So things for the API itself. So that was the separation that we decided to have. And for some of the things, we wanted some kind of pull request to guardrail on what is coming into the platform. So the platform itself, of course, if we're going to do any changes to how API management is configured, we're doing that with Terraform code, but we will have a pull request so someone can actually review what is coming in. The same for the products and groups, so the common components. When it comes to the API themselves, we don't enforce that. It's up to the different teams. They are working in different ways. So we give them that freedom that they are free to do that the way they want to. But the process itself is controlled through some templates. And we come to that. Mihai?
Well, this is a simplified overview of what we ended up with. So as Samuel mentioned before, we wanted to treat the product configuration, groups configuration, API configurations as a software problem. And by doing that, then we can apply software engineering practices that we currently use to develop our applications, like version control, pull request with 4 eyes principle. We could have automated testing on it. We can have some linting, styling, and so on. And if we deploy this we can link work items to a change. And if we deploy this specifications or these descriptions of how our APIs look like through the same software delivery pipeline, then we manage to make these changes repeatable, auditable, safer, and easier to observable. We can track them, right? Yes.
Is it common that like for inexperienced customers or some in API management more tend to use the portal? So let's say if you don't get it like this, you don't have the traceability and such and the auditing as you just talked about.
I would say it's not uncommon that it's clicking that in many cases, that at least my experience, that a lot of people do it that way, yeah.
By clicking, you mean?
By clicking, yes.
Good. And so how we did it is that we ended up with several repositories, right? Some of them common, some of them are team or applications specific or API specific. So we obviously had an API Terraform repository for deploying both the APIM instance and the resources needed for us, keyboards, networking, diagnostics, dashboards, and so on. We had a common repo that describes the products, since products is on a high level. On the product can contain several APIs. Then we have a common repository that is shared one per API instance that is shared between the teams, right? Where we define products and groups. And then we also ended up with a common repository where we have templates, reusable pipeline templates, and even Terraform code for deploying the API. And then we had, obviously, this is team specific or application specific, an API configuration repository. As we can see, let me try this thing, see if it works. As we can see up here, so we have an API. We can put this API specification or description of how our API should be deployed in the same repo as the application code, or we could have a separate one. In this example, we use a separate one, right? And then after we have several options, obviously, after you publish and deploy your API to whatever hosting model you want, from serverless, cloud native, or platform as a service, then you will have another step to publish the API, the new API, to the corresponding API instance for that specific environment. And here we will have two options. You could either come with API specification, open API specification that describes all your endpoints, requests, and so on, or you could provide a link to an API, open API specification, or the SDL, and so on. And we will go a bit later on through how that specification file looks like. And then after we deploy, we have a Terraform file for each API, so that it's easier to track the state. Good. And then obviously we had the pipeline for deploying the infrastructure, a pipeline for deploying the groups and products, and several pipelines for deploying the APIs.
Yeah.
So you have an API for each environment. You just have a single environment with multiple products.
In terms of the consuming the APIs that have been published, and specifically like authenticating to them, do you authenticate first to the gateway, or is the authentication always handled by the backend, passing some token or something like that?
That's a decision for the individual API team. So you probably would like to have some, not just leave it to authenticating into the gateway, because if you get to the backend, you need to have some authentication there too. So but as part of this project, we sort of since the environment was so scattered, and you have this flora of APIs that were completely different, we couldn't enforce them to actually have anything at all in the gateway. So some will just use it as a gateway that we pass. So we have of course the like Mihai showed, we had an application gateway in front of it. It was another product, but the function that it passed, and so we have that kind of protection. But from the authentication authorization, we leave it up to the teams to decide, actually.
Yes, because it kind of sounded like a traditional way, having application gateway and that kind of protecting kind of the old-fashioned way in that sense. But then there was mention of having like monetization capabilities and things like that. And for being able to do that in API management, of course, you would need to authenticate the users or know who the users are, so that you know how you would build the actual users then. Yep. So yeah, for that at least you would need some kind of authentication, I guess. Yeah.
But we usually classify the APIs into two, internal ones and external ones. And based on the type of the API, we deploy some firewall rules, depending if it's public or not. But we also build some validation of the specification. For example, you're not allowed to have a public API with basic authentication. So we use, for example, Chekhov to validate our infrastructure, and then we built some custom tests for validating what they are deploying and if it's okay or not.
Yep. One thing that we actually didn't say is that was actually part of the requirement is that the customer actually have a landing zone that we come into that have a lot of networking rules and that we must adhere to. So yeah.
And that brought a lot of challenges for us as well, because from the beginning we had a strategy of multi-region deployments because we had different regions, but because of the network topology, we couldn't do that at the moment. And that's a later project to do.
Next round. Thank you. If we going forward looking at what do we need to actually deploy an API? We need the specification, something that tell us, okay, what endpoints do we have there? And that could be Open API specification, it could be VSDL. So those were some of the things that you can handle. So you can have different kinds of specifications that when you're releasing something into API management. Then you have the policies. So each team can decide what kind of policies do they have. It could be the JOT validation, let's say, if they have the authentication. It could be caching rules, that kind of things. They need to provide us with the set of policies that they want to be applied. So that is a part. And then we have a configuration, so telling us a little bit more about the API itself, not from the perspective of code, which endpoints it has and so, but it's more from the API management perspective. Okay, what products is this API supposed to be a part of? Do we have any name values? What are the name values for those? The value itself for it. Are those a secret or not? And it could be, who do we contact? If you have like 100 APIs managed by different teams, and you're sitting with an API management, who is handling this? And this could be Samuel in Göteborg, Mihai in Stockholm, or a team somewhere else. So that kind of information, also contact information, so we know who to reach out in case something happens in the platform. And this configuration can be done in different ways. So we have, if team wants to work in a sandbox environment and sort of creating the policies, creating all the configuration of it in the sandbox, we have a process to actually export all those from that environment. You can do it manually, so we have a specification where if someone wants to do it by hand, they can do that. Or you can, and that's something that became quite popular with the customer, that they actually clone a repo that we had. We created a demo for them, a demo API, and they actually cloned that and then work from there, changing the values to what suits them and add some more. And then also the pipeline. So we provide a managed template for them to use that they need to use, but they need to have sort of provide us this information for them into the pipeline to actually do the deployment itself.
I would just like to add that the custom specification also describes where we find our backend, what type of backend we are importing, and also the version of the API that you want to expose. so that we had support for versioning of our APIs.
Good, thank you. If we want to compare this with the resource kit that is in GitHub, that the Microsoft API Management team worked with this, but it's actually an open source project. And they, if we compare with it, they work with ARM templates. That was nothing we could use due to the customer's requirements. So it wasn't that we just wanted to invent something new. It was that the requirements from the customer sort of ended up in that we couldn't use it. And they have two different tools. One that is called Extractor. And for that, you need a configuration file where you actually specify basically the same things that we have in our settings file. So it's the same kind of information. So of course, it should be quite close. They create ARM templates for it, but we will use our configuration as input to the Terraform templates that we have created to actually do the work and get it into API management. Then they have a tool called Extractor that exports from a live, like a sandbox environment, development environment, export templates, ARM templates that you will send into the environment, and while the export script that we have created, instead it generates the configuration file that you later can work with, the policy files that you have, and the specification itself, it exports from that environment. So that is the difference. Any additions?
Well, it's kind of this approach why we didn't really like it. It's that at the beginning you could just you exported the whole instance, right? But different teams, different cadences. They want to release to dev, but not all of them want to push or publish further to the test or production environment, which was and then it also breaks the principle of specify once and deploy several times. So that's why we dropped this idea.
Yep. Okay, good.
And we couldn't track changes as easy as we do with help of pull requests, connecting work items to it, and so on.
So now to the more fun part. So some demo and see what we actually have. And we have some two different projects to show different perspectives. So first is ski area API that we will have. We have a pipeline for releasing the API itself. So we own the API. We want to release the API to an app service in Azure. And also we have releasing the API into API management. So that's we own everything. And then we have the conference API. That is, we don't own the backend. So it's a service that we have the specification. We know which endpoints to go to, but we don't own the code, so to say, or to where to go. And we're not intended to do any release on that. And this could be, let's say that you have created a specification for reaching, let's say we talked about service now today, and that could be, let's say you have some APIs that you want to expose. So you could actually create a specification and you go to the backend that could be there. So two different approaches. Ski area, we own the entire package. And the conference API, we are only releasing the specification and the settings into API management. Yep.
So, for example, they have some legacy investments like old ERP systems, and they exposed just a few endpoints. So they wrote their own open API specification for how want to, how that template looks like, that we set up pipelines for it.
So, okay, let's go to the code. So we have, if we look first on the repos that we have. So we have the repo for infrastructure as code, where you have all the different Terraform files and so on, and then you have all the other different repos that we talked about. And first, we are going to talk about this key area that we have here. And for it, we have, if we go to the pipeline directly, just to see what we have there. Let's see. You can see the code. Okay, so we have some stages here. And first we have one to actually build the API itself. So, and then we deploy the API itself. We have actually just deployed it to one backend. We cheated a bit, of course, to save costs. But then we have we publish artifacts, and here we have we start working with actually the code. We're going to look at the specifications and so on also. But here is where we start working with that data and actually publish it. So we have the files that we need to actually do anything, and then we have the stage to actually do the deployment to the sandbox environment that we have. And here we have a template. Any comments on the template?
Not really. We have like a common template that can be easily injected into the existing pipelines, or we have a baseline that sets up the whole pipeline for you, to each stage, right? So it's up to the team to decide how they wanted to use them. But we provided both support for both ways. And the common templates are just calling the Terraform code for provisioning or deploying or the API to the API based on the backend type. And we have support for on-prem random APIs, right? It doesn't really matter where they're hosted. We had support for app services or PaaS model. We had support for logic apps and Azure functions. For Azure logic apps and Azure functions, everything was done automatically, all the configuration for it, and even VSDL, right?
Mm-hmm.
We had support for SOAP.
And the cool thing here is actually, you see it says template here. So this is a template that we have provided to the team. They can't change the behavior of the template. So that is the way we control how the API actually gets into API management. So the only way for them to actually get the API into API management is through this template. So they provide us the information and we use that. And then we do the deployment. And here you see we have API specification, and we have written this a JSON file that we have. And then we have also here the other variant where we actually have an endpoint that has the specification. So it's up to the team to decide how do they want to have this exposed. And that's yeah, it's their freedom to choose. So this way they can actually they decide how does the pipeline look like. But the parts that are for API management, the interesting part for us is completely controlled through the template. And they have read access to the repo, but they can't do any changes to it. So that way we get control.
They can create pull requests to improve this.
Yeah.
We want to have this inner source culture, but they can't. They need an approval to merge in the changes.
So we can have a stage for each environment. So if we go from sandbox to dev to test to production there. And one thing that we do, if we go into here and see, one of the things we talked about that we had some validations. So we actually do, one of the things that we do is that we execute some tests. And if we look here, let me see if I can expand this. Am I blind? I have. So like that. So here you see that we have, can we, this way, like that?
We could use this. No, doesn't work on your machine.
You have a special machine.
Yeah.
So here you have a set of different tests that we have done and looked into all the policy files and see if they do something that break the process. And that could be, let's say that we think we find a password in clear text in the policy file. It happens, I promise. And it could be that you have in the policy files, it's a hierarchical structure. And if they at some point remove an element called base, that actually says, okay, go to execute the code in the next level. If they remove that, they remove from the platform actually the rights to sort of apply some policies at a higher level. So by validating that they have removed and the build or the release breaks if they have removed it, then we have control. So that is, we defined a set of rules that was logical for the customer, and that it ended with this. And we have also included a process to actually for exceptions, because we knew it will definitely be that there will be some kind of exceptions. If you have like 100 APIs and some of them been around for quite a while, you will have some things that are not optimal. So we have sort of needed to have that included. So okay, do you think we should start off one and just get it to release? So we just get it. It is deployed, so we skip the build and deploy, and we deploy to the sandbox and to the dev environment. Did we have any approval there in between them, or did we? I think so. This is something we could have approvals between each, just straightforward, common work with Azure DevOps.
For deploying the APIs, we could enforce approvals because it's not the platform team that owns the environments. It's rather the development team that owns those. So it's up to the team to enforce them if they wanted to.
So we started and we let it run, and it will take a while. So meanwhile, we can look at the things that we have in the backend, the code, so to say. And we go here. And we have this key area. So I told you that we needed some kind of information. You can see. Yeah. Okay, good. So we needed the specification. So here we have, in this case, we have the Open API specification. So you could have a link also, but in this case, we have that. Yes? This is, I mean, it's a global, it's a standard. Yeah. So basically, if they provide us with a link, the link will go to a file like this. And it could be WSDL for if it's SOAP web service in the backend, it will be BSDL instead of Open API specification. No, I thought you sort of was on the run. And then we have the settings file, and here we have some interesting information that we have. We need a unique API ID, and for the customer we have some recommendation on when it comes to naming, having versioning, and so on how to do it. Some display name, the backend. Some description, and here we have something called solution ID. You have some in every organizations when you have a lot of different systems, you need to have some kind of identifier for the system itself, and it could be eventually controlled in some system, or if it's just something someone has in a drawer. But solution ID, that was important, and in the documentation for the customer, we pointed out you get this from there, and that's and then some contact information that it's just a string, so it could be talk to Samuel, or it could be an email address or a phone number or so. We want something to be there, so that's what we validate. And then we have telling if this API is public, open to the public, or if it's internal. And depending on that value in the Terraform code, we do different things. Then the path that will be in the address for, so this is information that we actually get from if we export, we do that that way. Yeah. Which protocols? HTTPS it should be probably the most common, and not have any HTTP. And then information that we need, like subscription headers for the different keys, versioning. Then we have policy information of the policy files. So we are saying, okay, for this operation, we are using this policy file. And so they can have how many, basically for each operation, if they want to have a specific policy file, they can have that. And we have one that is for all operations there. Then we have a list of the different products that are should be applied. And then we have name values and backends also. If they're using.
In the name values, there is a type. If it's secret or not. In case it's a secret, it shouldn't be in the code, right? That's a no-go. But if you have a name value that is a secret and it's something that you need for accessing maybe the API, then we will create an entry in a key vault, and they will have to update those values manually. So our API management will read those secrets from that key vault.
And that was one of the mistakes I did when my test didn't work. I actually forgot to go into the key vault and add the audience that I had as a secret. So that was the reason why. And then we have here a YAML file that is a sort of starting point for the team. So we create a template that they, for using the template. So when they do an export, they can actually get the YAML code to do the deployment of the API. So we wanted really to make it easy for the teams to do the deployment. If they have their own pipeline, they can actually take part of this code and paste it into their own pipeline code and just get it working. And then we have a folder for the policy files. So, and those are just what we have exported from API management. And to export, let's see if I have some nice terminal. We have a not especially fancy, but it's a PowerShell script. And we're telling first, okay, what kind of environment is this? Select the folder where to do the export. And then we select, okay, I have several subscriptions. So I select this subscription. What instance of API management? And let's say we have the Echo API in this case. And it starts exporting a file, looking and see that, okay, there we have some policies there. And we have created something, exported something. And if we look here, we go to exports. And we have the Echo API. And here you see that we have the Open API specification, we have the settings file, we have the YAML, and we have the policy files. So and this is what we actually, so basically now we just need some tweaking. If we have some values that will be most likely different on different environments, create the normal handling in the release pipelines to get that into API management. And just going back to the repo. Okay, it's done. Oh, it worked. But if we go to the repo, so we see here, just to see the difference between this and the conference API. So here we have the API parts with that I showed you. You have the folder with policies, you have the different the specification settings and so on. And you have then the other parts that are the rest of the application. It's the bicep code for releasing the infrastructure for the API itself, and the code itself. We're not going to look into my code.
Are you afraid?
Yeah, sort of.
I'm sitting behind you, right?
But anyway, you have that code, the entire package, so to say, in one repository, and this is something we let the teams basically decide themselves. And if we compare that with the repo of the conference API, and we see here that, okay, what do we have here? Yeah, we have the pipeline, and we have only the code for that we need to release. Nothing about this sort of how the backend works and the infrastructure for that or anything like that. And this is something that we wanted the teams to actually have that freedom of decide, do they want to do this as one package, or do they want to do the API on one side and the release to API management on the other side? Anything you want to add now? Let's look at the release. Let's see if we have some failed for policies. To see if something that is failing here.
You get the failed ones. You have the pass percentage.
Okay, yeah, thanks. Okay, so I promise it's sometimes it fails on that. Okay, anything you want to?
Can we take a look how it looks in the API management?
Yes, definitely. You want to show that?
I guess I can do it, so otherwise they're doing a great job.
So if we look here, we are in the dev environment, and we have the released API here. So we have the version 1. We have this key area API 1. Did I do something? Okay. So now we have the operations. Slow it like this. And if we look at the all operations and look at the policies, and we see that, okay, we have some released policy. And we can see that we have on some of the other, we have some policy there also for setting some header. So we have applied actually the policies that we had in the process. And also we have, if we look here, we can look in the settings. We see that it's taking time, slow network, or could it be Azure?
Auto-scaling.
So, and here you see that we have some products that we have coupled the API with, and those were the ones that we had on the list. And we have also, if we look here, we have some name values that we have applied here, and you see that we have some of them that are connected to Key Vault here. So it gets the values from Key Vault there and connected. Sure. Anything more? Do you want to show a bit on the Terraform, just a little bit on how that looks like or something?
Yeah, sure. Take a look. So
I think we have time. Yeah.
I have a few extra minutes, right? So what Samuel didn't really cover was the products and groups. So we have a separate repo for that one. And usually the products are deployed here under the products. So we could see that we have the ski resources product, and probably the ski area is part of this product. We can take a quick look at how the products, it follows the same thing. We have a JSON specification describing the products. And then those products are then used in the API. But let's take a quick look at the infrastructure. So the infrastructure it follows kind of the standards. I have a main, nothing more complicated than that. Here we deploy we have modules for deploying API, and so a common module for deploying Key Vaults, application insights, and other resources that are needed, like dashboards and log analytics and so on. The developer portal was also a kind of a sort of a challenge to get out, to customize it, right? So maybe someone would like to say a few words about that one.
Yeah, there is a process to actually extract extract the code for the developer portal, and the approach we took is that we can tweak and have some placeholders in the text. So the customer wanted it to be somewhat viewable, that okay, here we are in the development portal for the dev. Here we are in the one for test and eventually for production. I have to see some kind of difference. So we had some placeholders there, and that we tweak that in the sandbox environment where we create, and then we export that, and in the code, in the Terraform code, we actually do, or in pipeline, we do a replace of these placeholders with variables that we have in the normal process, and that way we sort of get in the code into the developer portal there.
Since this is kind of standard, maybe we could take a quick look at the publishing template. So here we have a template for publishing the API. And here we obviously take in the API specification, API configuration, where we describe how the API should be deployed.
You can make it full screen if you want.
Working directory, and obviously the environment that we're supposed to deploy. And the Terraform code that we call here. So we have some modules. This is a demo code, right? So might not be the best code, and we might find commented parts. But what we do is basically we read that API configuration file. We check what type of backend we have, and then based on that, if it's a function, then we will call this module the module for a function app. If it's a logic app, then we call the module that we wrote for the logic app. The logic app was a bit tricky. It wasn't easy to get out the seed to access to call it logic app. So that one was a bit of a hack, right? With Azure CLI called from Terraform. But otherwise, other than that, it's just a standard code, easily to get to work. I don't think we had many other challenges for setting this up. Also for making sure that they are using the templates, there is a feature in Azure DevOps that you can allow to access to a connection, service connection, if it comes from a template. So that feature we used also to be able to be in control.
Perfect. And that's the only service connection that actually is allowed to do the deployments to API management. So
good. Any questions?
Yep.
When you add a new version of an API, do you just add it up, increase it?
Yeah, you create a V2 and decide what to do with V1. So you if you want to do some kind of changes, let's say that you still want to have V1 for not breaking the V1 clients, you can actually create a V2 and do a deployment of V1 with changes actually directing to the new backend, with eventually some tweaking in some policies to actually do the right call. And have so it depends, and will depend a little bit on what we intentionally did not include in this was revisions. So we still leave, if there is something that we need to change, or for some good reason, let's say in production, we need to do something, a hack, let's say, to be sincere, then we actually allowed to create a revision there. So it was nothing that I remember. Maybe it was implemented but not used.
Yeah, so we have support for revision, but it's not something that they will use or are using currently. So it's not much tested, that flow. Yes?
Could you implement throttling basically with the API management gateway, to make sure that the backend is not like overloaded or yeah, things like that?
Yes. So what you could do is you could just add a new policy file. So for example, if we go back to the ski area, in the API, you would have to add a policy for the API for the throttling, and there you will define what limits you want to have, right? Two requests per minute or 20 and so on.
And how you edit the policy file is basically up to you.
You can try it out in the portal, right? And then save it and put it in the code. You could, if you're used to writing policies file, then you can just do it in code. If you experiment something in the APIM by hand, we will override those settings anyway. So.
Yep.
Questions. First question, why not assign it the value for the secret in key vault right from the pipeline? I mean, you have principal, you have access to create key, but the secret key, but not the value.
Can you just repeat the quick?
I mean, you have access to key vault to read the secret. You can, why not granted this service principal access to create the secret, the new version of the secret?
So we create the new version of the secret. We create the secret, but from where should we take the secret value? We don't want to have it in code. We don't want to spread it in Azure DevOps. We want just to have it into one place. An option that we discussed to add is that the teams can bring their own key vault, and they can give permissions to us to read those secrets from their own key vault instead of having a central one that they will have to update later on.
But how can they bring? They created some kind of a new principle to this connection to.
Well, they will give permissions to the APIM to read from their key vault.
What secret do you mean?
Well,
You can have application secrets.
Yeah, application secrets.
Yeah, exactly.
Authentication.
So, for example, some APIs that you want to expose, you might have some legacy investments. They don't have support for modern authentication methods like Auth 2.0 and so on. So then it might have some sort of access key or API key that you might want to save in the API will need it to forward your request, right? And for the customer, then you could use like session or what is it called, a session key or API keys from the API man or other authentication methods, right? More modern maybe. So those kind of secrets we kind of need. For example, we might need a key for accessing the Azure function, logic apps. Those we deploy automatically. But if it's some other systems that we can't read the keys and save it in the key vault, then they will have to do a manual intervention there. Yes?
Maybe it's the last question for me. No.
You should stay behind.
Question about like integration testing. So the API is released, backends probably healthy and etc. But maybe there are ways to test that API really alive. I mean, not alive from the health probes in the API, but from the pipeline. So it's like the last step to validate that some HTTP call or some request is really reaching out the backend.
Do we have those tests? I don't think.
No, we didn't have it. One of the things that we had that since we had so many different APIs, you would actually would need to give fixed access for the pipeline to actually call all these APIs, and some of them had some kind of like ping functionality, but most of them didn't. Then you eventually sort of you can have if you eventually could have some kind of get or so. So I think we along the way we decided not to have anything like that.
It was on the agenda though to have some sort of sanity checks.
But would you recommend to do this kind of stuff if you deploy an API in general? I mean, some kind of a health check if it's.
If you have the health checks implemented, yes, definitely, it's really nice because then you could have the health check could be something that is open. So you actually you need no authentication or authorization to actually call this health check function, and for that, yeah.
In general, it's always good to have those. I mean, even if you have availability tests on your APIs, you might have some networking issues between or connectivity issues between the API and the backend. So it's always good to have those, at least for the on-prem services. That's even more hops to reach the backend.
So some more question? Anything online? Yep.
Do you have separate pipelines for the application on the API? Yeah. So you could deploy a fix, but not need to deploy the whole API.
We leave that to the teams to decide actually. So in my case with the ski area, I could actually release just the stages for releasing the API and skipping the ones going to API management and not touching that. So that could definitely be done. But that was something we left for the different teams to actually decide how they wanted to handle that kind of way.
Or you could simply have two different pipelines, one for deploying
Yeah.
API, the application, and code. And well, we did both, to be honest. So, and then another pipeline for just deploying the specification, and then that could be even manual trigger or on commits, or as you wish.
And one thing, if you implement something like this, I would recommend to actually document this. I wrote most of this. So probably why I want to show it. This is we have removed some information here that is sort of specific for the solution we created. So this is not complete. It's something if we implement it with another customer, we will add the specifics for that customer. But here we have just, of course, an overview. Then we have some prerequisites, how to develop an API in the sandbox, explaining how do you export, what do you need. That, I mean, normal information that you need for the process. And if you're creating something that like this, it's really important to have this to avoid having all the teams calling you and say, hey, I have this and I want this to be released. And we also have like created like a step-by-step doing in our case was, okay, we do it with clicking. This is the way you go into API management. You add the API, you do the configurations, and then you set the backend, you work with the policies and explaining how you work with the policies and links to information. So we don't get the calls on how do I work with policies. we provide the information, and in some cases we have some guidelines on that, and then we have more specification like information for the settings file and so on for them to work with. So yeah, so this part is as important it is to actually get the APIs out working for the adoption of a process like this. Documentation is, I would say, very, very important.
Any other questions?
Any online?
No, I'm looking at the online and the chat.
Okay. Do we say that's a day?
Yeah. Fine, I think. But next.
Oh yeah. Yes.
I get you to publish this on the meetup as well in PDF format or something.
Yes.
Yes.
So since there are no more questions, we have some reference on what's coming next. So the next one, the next meetup is GitHub Copilot, 22nd of February, and then what we have in mind for the sessions afterwards, we don't really have a date currently, but we plan to look a bit of enterprise planning with Azure DevOps, feature management, what's new in Octopus Deploy. Anyone using Octopus Deploy here? Anyone interested to find out? Anyone has used Octopus Deploy?
Yes.
Anyone interested to find out what's new in Octopus Deploy?
Yeah, why not?
Okay, good. Just checking. Testing with Playwright, Postman and Azure, and maybe we'll have a session on GitOps with Argo CD or Flux2 and AKS. Okay, thank you very much.
Thank you for your time.
Thank you.
Thank you.
Thank you from online.
Thank you.